Welcome to the presentation on, let's get past the syntax, the real scares in the semantics. I really wanted to give this talk because when I work with developers, oftentimes, we tend to really stumble upon syntax. Everyone does that. One of the things I have the most difficulty with when I start a language is trying to figure out the syntax. So I thought it would be a good idea to talk about why that's really not as important as something else that's really more important, which is the semantics. But before I get started, I want to talk about today. Today is really a special day. Does anybody know why? Because it's Tuesday. Today is Turing's birthday. Well, Turing is considered to be the father of computer field. He did some amazing work when most people didn't have a clue how to create systems that could actually do a lot of things that modern computing does, modern computers do. He's attributed to his vision. So it's pretty amazing to think about somebody who has been through that and created something so spectacular. So it's definitely a pride moment for me to think about what he has done for us in terms of his sharing his passion and vision. Well, I want to talk about what we run into often. We run into perceptions, and every single one of us go through this perception. And perception is human nature. There is absolutely nothing we can do about it. And so if you really think about it, look at this particular picture for a minute. What comes to your mind when you quickly look at it? What's the first thing that comes to your mind? Most of us probably saw that vase right in the middle, but some of us probably saw the romantic faces on the side. Anybody saw the romantic faces on the side? Usually the young ones, I think, in the room, right? So, yeah, some of us see that. Others probably saw the vases. Well, can you focus your eyes and keep one for a long time and look away and look back? What comes to your mind? Well, that's human nature. What we're going to see is very greatly influenced by what we have seen before and what's in the context, what's in our mind. And we have to deal with this kind of perception all the time. And when we start coding, we have to deal with that as well quite a bit. But on the other hand, when we work with things, our perception often ends up limiting what we can do and what we can work with, because it's often a constraining point at some point, because what we are familiar with greatly influences that as well. So given this, if you look at this code, what does this code look like? It would be so much fun to just throw that code out and see what people tell. And I've had people, I would go and speak in a conference, and I would have people come to me after the talk, and people would say different things. Like one person came to me and said, oh, that looks like Scala code. Another person came to me and said, that looks like Groovy code. The strangest I've heard so far was one guy came to me a few months ago and said, that looks like D3. And I'm like, what in the world is D3? It's like, oh, that's a JavaScript library. Oh, of course, but why would it look like D3? It's a library, not a language, right? But that's the fun part. What people know about, they associate things to that specific thing. That's just the human nature. So to think about this, I'm going to talk about this nice vegetable. Well, I honestly don't know what the name of this in Polish, and even if I try, I would mispronounce it. I won't try. But of course, I could ask, what's the name of this? And most people in the US would tell you that this particular vegetable is called eggplant. Now, you look at this and say, why would this be called eggplant? Does it look like an egg to you? Or does it look like a plant to you? Neither one. So why? So, of course, it's an eggplant, but why is it an eggplant? Well, it turns out a variety of vegetable look like eggs, goose eggs, to be precise. So in certain parts of the world, this is called as an eggplant. Well, okay, that's cool, so what about it? Well, I was actually having lunch with a group of people from different countries. I actually was in Belgium when this happened. And we had people from different parts of the world. And one of the guys from the UK he suddenly blurted out saying, it's kind of funny that Americans call this eggplant. So I said, yeah, that's kind of funny too, that it's called an eggplant. In fact, being a vegetarian, I would not want to eat it if it's an eggplant, actually. It's got egg in it. So the point really is, why is it called eggplant? I blurted out, and I said, well, of course, that's brinjal. And he looked pretty shocked, and he said, what the heck is brinjal? And I said, of course, how could you not know what a brinjal is? Brinjal is the English word for eggplant. And I was telling this to an English guy. It's not going to go well. So in India, they called this brinjal, and he rejected and said, of course it's not brinjal. And I was kind of shocked because all my life I knew this as brinjal, and now it's not brinjal anymore. And I said, what do you guys call it? And he said, well, we call it aubergine. That even made it worse. And how did that become aubergine, and where did the word brinjal come from? So that got me really curious, right? Everybody taught me English word for this is brinjal, and apparently it's not, because the guy from England says it's not. So he's got to be right. So I immediately emailed my wonderful uncle, who is a professor of English, and said, what am I missing here? And he replied back saying, aha, you got tricked. Brinjal actually is a Portuguese word, not an English word. You should see the surprise I had. Well, Portuguese ruled India, a small part of it, and the only thing they left is the word brinjal now, right? And it's kind of amazing, and now everybody in India thinks it's called brinjal, but the rest of the world doesn't have a clue what it is. But it turns out the word aubergine and brinjal, they both actually have a root in an Arabic word, and that's where it actually started. Go figure. And it's quite fascinating when you start tracking roots of words and the usages and how these things are related. It also quite nicely brings my ignorance about what I think I know versus what the reality is. So things get very interesting when you start looking beyond what's obvious and start digging a little deeper into these things. And almost everything we come across is like that in life, and programming is no exception to it. But syntax often hits us first when it comes to programming, because that's what we look at. Now, I have to tell you that I've never come across a language where the syntax made absolute sense the first day. In fact, to a great extent. I would like to program in different languages. I can dangerously program in about 12 languages. But when I start learning a language, the one thing I readily ignore is actually the syntax. Because no matter how much I try, I can never, ever remember the syntax. So I would read, I would understand, I would maybe close a book or close a tutorial, I would start coding, and it would hit me. It's like, what do I do now? What do I type now? Is it one arrow? Is it two arrow? Is it curly bracket? Is it parentheses? You can never really get this, and it only comes from practice over time. And so syntax is something we all look at first, but it often is really not helping us to look at the syntax. So given this, I've never come across a language where the syntax did not really take effort in the beginning to pick up the language. It really takes a lot of effort over time. Having said that, even just about anybody you can think of, even some of the experts we consider to be experts, fall into this particular problem because we all are humans. So Michael Feathers once tweeted, "First glance, I usually hate the syntax of new languages, especially when they are C-derived with pointless syntax variations start fresh." So he is actually calling for a new syntax than trying to reuse syntax. But if you really think about it, why does Java code look like the way it does? In fact, even worse, why does C# look like Java? Why does Java look like C++? And why did C++ look like C? There is a very good reason why language designers preserve the syntax. And the reason is programmers hate looking at a different syntax. So they decided, if I keep the same syntax, at least I remove most of the complaint, adoption can become a lot more easier in general. So they're not just keeping the syntax very similar arbitrarily. There's a very calculated move in keeping the syntax very similar, because adoption increases when at least that's one hurdle you can remove out of the way. But having said that, we see this quite often among people, programmers. And I saw this tweet that says, "Ruby is an awful language. I hate natural language syntax." Yes, I'm looking at you too, AppleScript. Well, in this particular case, this particular programmer is talking about how he hates the Ruby syntax. Well, to me, I actually don't care about the syntax at all because there is so much that we can do once we look beyond the syntax itself. Like, for example, let's get past that for a minute. If you look at languages like Java for a minute, what do you normally do in a language like Java? You normally say something like, new, and then you would say my class. Well, that's with a semicolon, of course. So that's the Java syntax. But if you do this, what is this word new? New is a keyword. Now, we know one thing very clearly in language like Java, new is not polymorphic. Now, when new is not polymorphic, what do you normally do? You create patterns. You have abstract factory pattern, factory method pattern. Why do you have all those patterns? Because we Java programmers can celebrate. Hey, I can use this pattern versus other pattern. Well, in general, the more patterns you see is a reflection of deficiency of the language. We got more patterns in Java because the Java language, in this particular case, a case of abstract factory method, well, new is not polymorphic. So to get around it, we got so much cruft built up. But what if a language can mature to be that way? So let's take a look at one example here. Let's say I have a class called my class over here. I can simply say in this case something along the lines of my class.new, and I can create an object readily. But notice what we did here in Ruby. We said .new. Well, new is polymorphic because new is a method on the class. Well, class is an object as well, so you can pass any class and you can start creating objects with it more readily and easily. Languages can start providing that. That's not just a syntactical difference, it's a very semantical difference because it's polymorphic in nature. That's what you have. And one other thing that really fascinates me is, suppose I had a class here called my class. Let's take that for a minute. And I'm going to say here is an accessor for some value. Let's call it value for a minute. Well, I could then say, for example, define over here instance equals my class, let's say .new. And I could even say instance.value, let's say equals 4. And I can simply start creating stuff with it. Now I can say puts instance dot, let's say inspect, and I want to take a look at what's inside of this particular object. Well, clearly notice it says value equals 4. That's a field that's been stored in here. But here comes the real charm. If I remove that particular initialization of the field, notice it doesn't say what the field is. That is another thing that's pretty fascinating. When you create a class, when you create an instance of a class, it doesn't get populated with all the fields. Fields are extremely dynamic. So depending on what fields you actually touch upon, only those fields come into picture. Other things are not even present in the memory. That's a very different model than what we're used to in Java, where, of course, when you create a class with 20 fields, every instance ends up having those 20 fields, not the case in a language like Ruby, for example. And one of the really interesting things, again, is about expressions. Think about statements versus expressions for a minute. When you program in Java, you have if statement, you have a for statement. If doesn't return anything to you, for doesn't return anything to you. So which means when you have a statement, the only thing you can do with the statement is cause side effect. You cannot call a statement and expect nothing to be done, because a statement that doesn't do any side effect is a statement that does nothing, period. So statements fundamentally lead to mutability and side effect. Well, in functional programming, and as we're embracing functional programming more and more, we are beginning to realize statements are not really that good. We should program more with expressions. But what if a language has no statements at all? What if a language only has expressions? So think about the name, the word class for a minute. Well, in Java, we use class. But what is class in Java? What is public in Java? What is static in Java? What are all these things? Well, we know that those things are called keywords. But what is wrong with keywords? Well, when you use a keyword in a language, you cannot use that word elsewhere, which is really sad, because if you really think about it, why did Java say you have to use a colon in a for each? You have to say for variable name colon and then the value from the collection. Well, they used a colon because they were so worried if they use the word in as a keyword, existing code would break. But if you really think about it, should we really have keywords that do such things? In my opinion, languages like keyword are like mafia. They take stuff away from you, right? Very merciless. Well, what if there are no keywords? What if everything is an expression and context on which you are using gets decided what you do with it? It changes the way you perceive things. So for example, here I can say puts class A, self, for example, here, and then end. You can see that I'm actually printing the result of the class. On the other hand, instead of self, I return something like a 2. You can see that gets printed as well. So the point really is a class itself is an expression in Ruby. So is private, so is public. All of those become expressions. It just changes the way you think about a language. It changes the way you would use a particular language. So to me, when I start programming in these languages, I push away the syntax and I say, what does this really mean in the context of the semantics of the application, semantics of the language? And that's really the exciting part. Here is another quote. I hate to say this, but Clojure seems to have a bizarre confluence of beautiful semantics and an ugly syntax which remains my Perl. That's a very tall order of insult anytime somebody compares to Perl, right? So Perl is called a write-only language. Nobody ever reads it. So, well, of course, it can seem like that when we start using some languages. But to me, again, when I look at language like Clojure, it's amazingly powerful. I don't care about the syntax because syntax is something you just have to get used to over time. But one of the really cool things about this is it's extremely concise. I can't imagine how concise a language could become. When I program in Clojure, one of the things that just fascinates me is the sheer conciseness of the code. There are times I would just pause and I would just stare at it and say, wow, how concise this has gotten. It's just amazing when you can get that kind of conciseness. So for example, I'm going to say define a list of values here. Let's say a few values, let's say 1, 2, 3, and 4. And I'm going to simply provide a little method here. So I'm going to print, and I'm going to simply say, in this case, reduce with a plus function the value in the list. And you can readily start printing the values, and you can reduce that. So let's call this values for a minute to avoid the conflict. So I can see, in this case, I can take the value, and I can reduce it. You can pretty much take an operator or a function and pass it readily. You'll see something similar to this in Haskell as well. So the reason to really create Lambda expressions is very minimum, even though you're using higher order functions. And that is something we can learn from that to say, hey, actually this is pretty powerful in terms of the conciseness the language actually offers in how we can send to it. Not only is that, in the case of Clojure, almost everything you create is automatically immutable. So for example, if I were to define, let's say, a value is 0, and I can go ahead and print the value right here. But if you ask me to modify the value, I'm sorry, I cannot do that. There's absolutely no way to modify a variable once you create it. That's immutability from the ground up. But of course, even though you cannot mutate it, there are safe ways to really manage mutation. And Clojure has this wonderful concept of separation of state from identity. So the idea behind separation of state from identity is that you have states which are immutable, and you have identity which really is mutable, but they call it a managed mutable identity. And you can very, in a controlled manner, using what is called STM, or software transactional memory, you can actually mutate it in a very safe way. So for example, in this case, if I were to put that into a reference, an identity right here, I have wrapped it into an identity at this point. Of course, value is a ref at this point. I can dereference it. But on the other hand, if I'm really interested in modifying the value, I could try doing something like this. I could say ref set, for example, value, and let's say 100, and that's going to blow up because it's an illegal state exception, not allowed to modify because concurrency issues and stuff like that would come and haunt us. Well, you can again go back and say, control it properly, and you can introduce a do sync around it. Think of this as very controlled and predictable synchronization, if you will, and you can see how it can manage that. So the identities are managed very well by the language level, the software transaction memory itself, and so we don't have to fear concurrency failure so easily. Well, here is another language being talked about. There are days when I truly hate Scala syntax. Well, once again, I would say, get past the syntax, what do you see? Scala is extremely concise, another thing that I really like a lot. So for example, if you're really interested in writing a class, in the case of Scala, how would you write a class? Well, let's talk about how you would write a class in Java for a minute. Class, let's say car, and then what would you say? You would say a private int miles, for example. Then you would say a private, for example, and then final, maybe int year. Are we done? Absolutely not. We have to write a constructor. So we would say public and then car, and then you would say int, whatever the year you want to set, and then the miles, if you want to set the miles, you would say miles equal to 0, of course, and then you would say this dot year equals year. Are we done? Of course not. We got to write the get method, but it's time to really take a lunch break, right? I know what you're thinking. You're saying, hey, no, I never do that. I only type the field, then I gently right-click on it, and then I watch my IDE vomit the rest of the code, right? So what we are saying is, not only we want a language that is verbose, but we want fancy IDEs to ship with it as well. But why go through all of that trouble? But rather than that, we can do something like this, for example. We can say, for instance, class car, and then we can say, here is a value year, which is an integer, and I want a miles, which is a variable, which is also an integer. Now, what did we do? We created a class. Hey, what else did you do? We defined two fields. What else do we have? We have already defined a constructor, and we have a getter, and we have a getter and setter for miles. All of that is absolutely done. And that's the beauty of the conciseness of the syntax. Every one of them is already done. We are ready to use the code. So we can simply say, for example, car equals new car. And of course, this will give me an error because I've been initialized the constructor properly. So I'm going to say 2015, 0 for miles. And you can see now it's actually happy. And I can print out car.miles, and I can get the values out of it. Or I can call the year, and you can get that done as well. You can see the code is extremely concise. Of course, you may say, wait a minute, if the code is becoming so concise, what do I do with all my free time? Go home, right? You don't have to sit there and work hard to write stupid code. And so the point is the language can come a long way and eliminate stuff that you have to do rather than IDEs come there to put more verbose code in place for you. But the beauty continues even further. For example, I could say greet equals, and then I'm going to say greet, let's say here, and I'm going to say hello, and end the greet right there. And of course, I want to come and print the greet here. Now, if you look at this particular code, you may ask yourselves, what are we really dealing with in this code? And of course, quickly we can say, that's an XML we are creating. But we really didn't. What we created is not XML. What we created there, unfortunately, is what we have done in a lot of different languages, which is a string. Now, think about this for a minute. How many times have you created XML in code, and every single time you put it into a double-coded string? Have you done that before? Every single time. And then you say, XML sucks. XML misbehaves. How would you behave if you're put in a string all the time, right? Poor XML is very angry, right? It's been deprived of its decency. Well, Scala gives respect, okay, marginal respect to XML as it deserves. So what you can do here is you can simply drop the XML directly in the code. So what you're dealing with is a citizen, a first-class citizen, and you can deal with XML directly in the language syntax. Well, this only gets better. You can use pattern matching, for example. You can say greet, and then you can call a match, for example, and so you can say catch. And then, of course, at this point, I can say, well, given this greet, I want to grab the message that's been given within that, and I can simply print the message that's been given to me. And you can see in this case, it's extremely simple to parse through a content and extract the content of this particular object as well. And you can see that's very, very easy to do, is to get the content out. So pattern matching is a very powerful concept. You can use it for several different types. And in this case, of course, we are using it with XML as well. Again, the point is, we have to really look beyond the syntax. The language has some really nice capabilities that it can provide for us. However, I think really this guy here, Chris, hit the nail on the head. He didn't stop his tweet there, but he really came out with the real problem most of us have. I think he nails it. He says there are days when I truly hate Scala syntax, but he goes on to say, or more correctly, I hate that I can't easily unwire my own Java C syntax comfort zone. I think that's really the problem most of us are facing. I think he nails it. He says the problem is not that the syntax is different. The problem is that I'm so familiar with the syntax I program in. And that is one of the biggest challenges we face every single day, is that we are so comfortable with what we do, it becomes really hard to look at something different. I can't tell you how many times I come across Java programmers who tell me functional style code in Java is very complex. And what they're saying is, it's different from what I'm used to. And when you're looking at something that's different from what you're used to, your mind throws fit. It's really hard for it to accept it. And the only way to fix it is to get really uncomfortable until the different one becomes comfortable all over again. And we have to work towards it. So we have to really get out of our comfort zone. That becomes extremely important to really learn something different, especially when the languages that we are using are themselves evolving to introduce newer way of doing things. We absolutely have to keep up with it to move forward. So having said that, it's really important for us to learn the semantics and practice the syntax. It is a very wrong approach to learn the syntax. And it's really in vain if we try to learn the syntax, because I don't think it's really possible to learn the syntax. So when we start learning a particular language, we really have to learn the semantics of the language and let the syntax quietly fall in place with practice. And so that is one of the most important things. So when I look at a particular language, I don't spend my time asking myself, how do I write this? Where's the curly bracket? Where's the arrow? But instead I ask myself, what is the semantics of this? What's the consequence of doing this? What does this mean to me as a programmer? And so the semantical essence is what we need to really focus on. And of course, once we are comfortable with the semantical meaning, we're going to struggle with the syntax no matter what. But as time goes on, we get really better at it to write it eventually, and we'll get better working with it. So to me, a true appreciation or understanding of a language emerges when we dig into the semantics of the language and not when we really look at the syntax of the language, because that's where the real power of a language is, and that's where real fun is as well. So let's dig into some of the semantics to think about where it can get really scary, because the syntax is something you will get used to, but the semantics is something that's going to stay with you for a long time to what it provides moving forward. So let's talk about a few things that has haunted us so many times. Remember the Singleton Pattern. Well, here's the definition of Singleton Pattern. Singleton Pattern is a pattern you will learn about in 5 minutes and take a lifetime to get it right. It's extremely hard to actually get Singleton right. And why is that? Well, the reason is the real goal behind a singleton is to really restrict the number of objects, usually to one, but could be a limited set of objects as well. So maybe I'm interested in creating a singleton. So let's say class, let's call it singleton. And what's the very first approach to creating a singleton? We would say private, for example, static, and then we'll say singleton instance, and then we could say equals to new singleton. We could readily create it right there. Then, of course, we could say public, let's say static, and we could say singleton get instance, or readily we can say return instance and be done with it. Well, what are some of the problems with this code? Well, the very first problem is it works for the first 5 minutes. Then we quickly realize we have been creating an instance of this quite readily, and we don't really wait until it's actually needed. As soon as the class is loaded, we are creating the instance in this particular case. So it's an eager creation rather than a lazy creation. But the problem doesn't end right there, unfortunately. For example, if I say get instance at this point, you can see that a particular instance is being printed. I can try this one more time, and you can see that the instance is being printed. Hey, it's exactly the same instance. That's wonderful. But what is going to happen if I say class? Well, if I say constructor, and then I'm going to say constructor equals singleton.class.get constructor. Well, let's say get constructor. And once I get the constructor, I can simply say, what about if I were to say something along the lines of output, let's say constructor.new instance. Well, I could get around and start using reflection and try to get around that particular object and create another instance. Well, not that somebody would there maliciously try to do it, but in a genuineness, you're taking a class reference and you're using reflection in code. Well, how do you know that this is a singleton? You're not supposed to do this. Well, you could do proper testing to eliminate it, but it still opens the door for a singleton to be created. Of course, if you run this code, I need a constructor over here. So import java.lang.reflect. And of course, in this particular case, you're going to notice that it's going to give us an error. Of course, the reason for the error is it's going to tell us, oh, we got to handle exceptions. We can fix that. So throws exception. As experienced Java programmers, we know exactly how to handle those exceptions. So in this case, of course, it gives an error. Hey, you don't have a constructor available, a public constructor. Aha, we declared it private. Well, we can go a step further at this point and say, we can put a little bit more, so we can say declared constructor. And of course, we got a declared constructor, and notice we bypassed it, and we are able to get around it. Well, you may put another 10 minutes and say, I'm going to fix that. And soon enough, a programmer says, I serialized it and deserialized it. Darn it, how do you fix that? Then, of course, we start into lazy loading of that. Then concurrency issues come in. And by the time you're done with this, the singleton pattern turns into a monster in front of you. And while you're looking at it, somebody says, I found another way to break it. Well, in Java, how do you really create a singleton? Well, sadly, some of the problems that singleton actually has also is shared by enums. So one way you can create a singleton in Java is to declare an enum rather than creating a class for a singleton. That's not very intuitive, but the reason behind is the semantical problem rather than the syntactical problem. Of course, in the case of Scala, on the other hand, you could simply say object singleton, and you are done with it. So object is a singleton baked into the language, and the language says, I will take care of every other mess for you. You don't have to deal with it. So again, the question is, do you want to really focus on the syntax issues and look at the verbosity, or, hey, what does it mean semantically? Well, a singleton is a semantical concept I want to deal with. I don't want to sit there and struggle with it. We can look beyond that as well, checked exceptions. Checked exceptions have always been a nightmare. There is no really good answer. Is checked exception better? Is unchecked exception better? C# clearly went the direction of unchecked exceptions. Java went to the direction of checked exception. And of course, checked exceptions have really made it hard for us to evolve APIs, but not having those also is quite problematic. So we really haven't quite figured out how to really deal with it. But it really gets worse when you are required to handle exception in cases where it really doesn't even make sense to handle those exceptions. And that's when it becomes really annoying and it begins to limit what you can do. But to some more fun things. Multithreading is really awesome because you can create thread very quickly and then the fun really starts. But what's really wrong with multithreading? Well, it's a very complex abstraction, details that's been built around an abstraction, but unfortunately, that's a very broken abstraction. Well, it turns out most programmers programming concurrency on the JVM, me included, had not really taken the time to learn about the Java memory model. Well, Java memory model talks about how and when the data goes from the working memory, registers and caches, from the working memory to the main memory, or from the main memory to the working memory. Well, it turns out there are very specific times when this particular transfer happens. We call it crossing the memory barrier. Well, the problem is this: if we have not taken the time to learn about the Java memory model, and we start programming with threads, the behavior is going to be quite unpredictable a lot of times, and we deal with bugs, and it becomes extremely hard to deal with such concurrency. If you doubt that, I highly recommend reading Brian Getz's book, Java Concurrency in Practice. Well, Java concurrency in practice is considered to be like the Stephen King novel for programmers. It's extremely scary when you start reading it. Well, before I read the book, from what people told me, I realized I could not possibly program concurrency properly if I never read that book. Well, after reading the book, I'll tell you, you can never get concurrency correct. And that is the complexity that's involved in it. It's pretty scary because of so many different layers of things you have to worry about. It becomes enormously complex. So for example, let's say for a minute I have a static Boolean, let's say done over here, a little variable. Well, that's great so far. What I'm going to do here is put a thread.sleep for about a 5 seconds delay. And I'm going to then basically say at this point, output, let's say, changing done, and then I'm going to, of course, change the value of done, let's say, to true. So that seems very reasonable. The main thread is changing the done variable, so what could possibly go wrong? Well, I go back here, and I'm going to say new thread over here. Let's go ahead and start this thread, and within this thread, of course, I'm going to say new runnable. And within the run method right here, I'm going to write int count is equal to 0. And while, let's say, not done, I'm going to simply say count plus plus. So I'm just spinning through. And when it's done, I'm going to say ending this task. So a very simple piece of code, as we can see here. So we have set the done variable to be false in the beginning by default, of course. Then we start through the thread, and every step through the thread, we keep on counting the value while the done is false. And then the minute done is true, we bail out and print that we are ending this particular task. Well, if I go back and run this code, a good about 5 seconds of time later, you can see that it's going to print at this point that little message called changing done. But you can notice that the other message, which is ending the task, never got executed. We could stay here until the cows go home. But what's really wrong? Why doesn't it really work? Well, the reason for that is that we are violating a certain things we need to know about the Java memory model. Well, the problem in this particular code really is that this particular code right here, the compiler optimized it by removing the done out and replacing that into a while loop that runs forever. But why in the world did the compiler do that optimization? Well, the compiler does that optimization based on the Java memory model. And the Java memory model says, I haven't seen any calls in this code that tells me you have to cross the memory barrier. So what I have on my hand is pretty good. I can optimize it because I'm not going to go get a new value again. Well, but what would cause the Java memory model to cross the memory barrier? Well, therein comes the problem. There are several methods that would ask you to cross the memory barrier. For example, when you have a volatile variable, every time you read or write a volatile variable, you are crossing the memory barrier. When you call a synchronized method, not once but twice, you cross the memory barrier. Once when you enter and once when you exit. When you call a method, methods like start or join or wait or notify, or when you call the methods on the lock interface, all of these methods cross the memory barrier. Well, the problem is crossing the memory barrier is such a very important task, but there is no explicit command that says, now cross the memory barrier. Those commands have been quietly hidden around other things, and you got to know that you need to cross the memory barrier. But what happens if you should cross the memory barrier, but you don't? You have behavior like this in code, which becomes very expensive to trace and fix. But even worse, what happens if you cross the memory barrier when you shouldn't? Well, that may be a violation of invariant of object. Invariancy simply says an object will always be in a valid state. It'll always be viewed in a valid state. It'll always be interacted in a valid state. But what if you cross the memory barrier in the middle of, let's say, a constructor? So calling a thread.start in a constructor is absolutely a wrong thing to do because you may potentially expose the object state before it's ready. And we got to really face through the consequences of these depending on what we are trying to do, what version we are working with. A lot of these can change and get really messy as well. So in other words, threads are easy to create, but the threading model is extremely treacherous and it's extremely complex. So what does it feel like to do really multi-threading? I think Alexander Popescu really nailed it with this particular tweet. He said, in theory, multi-threaded programming is like this. But in practice, it's more like that. And we see this all the time. And that's how it kind of becomes really violent after a while. It becomes really hard to understand and maintain it. And we face this every single day when we start using multi-threaded code along the way. But what about programming with the list, for example? How does that really end up being really hard? So to understand this, let's take a little example and work with it. We all are used to imperative style code. We are happy with the syntax of imperative style code, so we are using it quite often. But what's going to happen if we try something like this? Let's say I'm interested in creating this particular example. Find the total of the square root of the first n prime numbers starting with k. Let's give it a try. How does this feel to write this particular code? Well, I want to know if a number is a prime number, so we can probably start with that, with the imperative syntax we are so used to. So I'm going to say Boolean is prime, and here is a number I'm going to start with. And the syntax is very comfortable, so we can quickly write that. So we could say, for example, in here, for instance, I equal to 2, I less than number, for example. And then we could say something along the lines of I++, and we could say if number mod I is equal to 0, meaning it's divisible, we'll return a false. And then if not, we will come back and say return number is, let's say, greater than 1. So that's a very simple code that we have all written, but more so, it's a very familiar code we all have written. But then comes the real fun part. We want to really go ahead and print out the sum of, let's go ahead and take a look at what we are computing, the total, the sum of the square root of the first n prime numbers, starting with a particular number. So let's give it a try here. So I'm going to call a function, let's say static double, and this is going to be compute int start int, let's say n. And what am I going to do at this point? Well, let's go ahead and pretend that it's done. I'm going to say call compute. Let's say we want to start with the 40, and I want a total of 50 values to be totaled. Well, that is pretty simple to write, isn't it? Let's try that. So int index equal to start. And then what do we do next? Int count is equal to 0. Well, double result is equal to 0.0. This is all very comfortable syntax. We are used to it. But what are we doing? There's a name for these variables. These variables are called garbage variables. That's basically what they are. We are creating them, and normally you don't call them index, count, and result because you don't respect them. You normally call them temp, t, and q because nobody will ever understand it, right? And that's basically what we do. We give poor names to these variables. Then what do? You say while count is less than n, and what do you do now? You pause, and you stare at it, and you ask yourselves, is it less than, or is it less than or equal to? Right? Do you ever do this? You do this every single time, isn't it? And the day you don't do it is when you get the off by 1 error. Nobody gets happy going home with off by 1 error, right? You go home and you say, look really grumpy. I got the damn off by 1 error again, right? We feel the pain all the time. Then what do? Then you say if, well, here is what, I got too many variables around me. Which one should I use? Should I use count? Should I use index? Of course, you got to think through it. So E is prime, in this case, index, of course. Then what should I do? Well, I'm going to say result is plus equal to math.square root of the index. Well, and then, of course, when I'm done with the whole thing, I'm going to return the result out of it. Well, are we done? Well, far from being done. Because if you run this code, you get this wonderful infinite loop to work with. So what do you have to do? You better come here and say index plus plus. Can I put index plus plus here? Sure, that'll be fun. Or you can put it here. Of course, I got to put count plus plus, but that's a lot of fun if you put it here. It better be inside here. Look at all the details you had to go through. And so what do you do with all this code? This is called suffering, right? And you endure this every single day writing code like this, and no wonder we are grumpy at the end of the day, right? And that is the amount of ceremony we have to go through. Look at the amount of effort, the amount of energy it takes to write this. Don't even ask me what's the energy it takes to read this code, right? I mean, that's why we never read the code. So it becomes really horrible to maintain such a piece of code over time. So now if we go back and try to run this code in good faith, it gave us that result, 615.61. Okay, great. But we can definitely do a lot better than this by writing in the functional style. And of course, it's a very syntactically, it's not a huge change, but semantically, it's a very big change. So going to functional style is a small step syntactically, but it's a huge step semantically. And that's what we really want. We want a small change in syntax, but a huge gain in semantics. Let's take a look at what we can do here in this code. Rather than that nonsense, we can simply say return number is greater than 1 and int stream.range from 2 to number, for example. And then I can simply say .none match, given an index number mod I is equal to 0, and I can readily say do that work for me. Now, if you really think about this, you can see in this case we have java.util. In this case, stream.intStream. Now, what did we do differently at this point? Notice that in this particular code, when I just run this code with what we have, it produces the same result. But what did we do at this point? If you think about what we have been doing so far, we've been using for loops. Hey, I want to loop through every single value. What do? A for loop. I want to loop through select values. What do? For loop with an if, with a break, with a continue. And if you keep going with this, every corner you turn, what do you see? A for loop. So this is like you hear a knock on the door, you open the door, and there's a guy standing there with a hammer. And he says, I'm here to fix your kitchen. And you say, oh, thanks for coming, but what about your tools? He takes a whack at the door and says, I don't need any stinking tools, I got a hammer. Well, that's called the for hammer, right? And we as programmers have been just using this for hammer every corner you turn. In fact, the managers think they could hire anybody who can write a for loop, right? That's the impression we begin to give because everywhere there's for loop. But in reality, what does a good professional do? You hear the knock on the door, and there's a guy with a bag of tools. He says, I'm here to fix your kitchen. You let him in. What does he do? He lays the tools on the floor, and you see a little screwdriver, you see a little chisel, you see a hammer, of course, and there is a wrench. There are many little devices. And you look at this guy and say, wow, that's really cool. And he says, yes, that's all the tools for my business. And you ask him, are you going to use all of them? He says, of course not. I'm not going to use all of them. Because the person who uses all the tools is called a consultant, right? So you're not going to use all the tools. So he says, no, I'm going to only use tools that actually make sense for the problem on hand. So the point really is, we use very specialized tools to get the work done rather than using that one hammer. So in this example, we can see we used a little method called none match, and we can start using these kinds of little expressions and methods. But what about this mess over here, which was so horribly hard to work with? Well, we can try this again. Rather than doing all that work, let's rewrite this. What I'm going to do now is I'm going to simply say, in this case, let's say I'm going to return from here, but where am I starting? Stream.iterate, so iterate from the number start, and given an element, give me an element plus 1. So if you notice in this particular example, I'm starting with the stream, but what does the stream say? It says, I'll start with the number start, but I'm going to keep counting one number at a time. But this is lazy evaluation, but this is an infinite stream. You say, wait a minute, it's an infinite stream. That's absolutely right. It starts with the number start, and it absolutely has no end. And you may wonder, if it's infinite in size, where do you store it? On the cloud, of course, right? So the point really is, it is absolutely infinite. So it's absolutely infinite in size, but it also has lazy evaluation. And as a result, it's extremely smart. It says, I'm infinite in size, but I dare you to ask for all the values. And of course, if you ask for all the values, you spend infinity waiting on it. But then what you do is you say, all right, I've got the value on my hand. Now I'm going to say filter, and I'm going to say sample is prime. From an infinite stream of numbers, you got an infinite stream of primes on your hand. And then you say, all right, now that I have all those values given to me, I want to simply perform a map operation. Well, in this particular case, of course, I wanted to find the double of those values. So I'm going to say map, math, okay, in this case, square root of the values. And I can perform a mapping operation. But then I say limit, and limit to what? Well, given variable is n, remember. So I'm going to say limit n. Did you notice one thing? It is not less than n. It's not less than or equal to n. It's n, damn it, right? There is no real confusion at this point. It's absolutely clear, right? And then, of course, once you're done with it, you can say reduce this to 0.0 double, for example, and then you can say sum, and you got the result on your hand for the computation. So you can see how the code becomes extremely expressive. Yes, syntactically, it's a little bit different. It's not new that we are calling a function after function and function. We have done this in builder pattern already, very familiar syntax. So the only difference in syntax really is using a little bit of an arrow here, a little bit of double colon here, and even double colon is absolutely not a problem if you ever use C++, feels home. So the point really is not a whole lot of difference in syntax, a few new things, but semantically it's a huge difference from what we have seen so far. Now, the beauty of this particular approach is you can see how expressive the code is. Now, look at this code for a minute. Syntactically, this is a fairly simple syntax. More so, syntactically, it's a fairly familiar syntax. But if you show this code to somebody and ask them, what does this code do? And then watch, just sit in front of them and watch their eyes after you ask them. Their eyes does this. Like that, right? Goes back and forth, and then it stops here, and then it's all dazed up. And they're not sure anymore, right? They're like, I think, I guess, I'm not sure, right? So you're confused at the end of the time. In the bottom one, your eyes go through a single pass evaluation. You start at the top and say, here's a stream of infinite values. I got a stream of prime numbers. I've got a square root of all the values, but I want only n of them. I want to total it. End of story. So the code becomes extremely easy to read rather than being very confusing as the code above was. So it is something for us to think about when it comes to coding. And we can, imperative style of coding, it feels like this. You're trying to teach a rude dog which will never learn, and every day you got to keep communicating with it. Whereas when it comes to a functional style, it becomes a lot easier to communicate that code as well. But one of the problems we constantly run into when it comes to programming is we accidentally mix multiple things together. We see evidence of this over and over and over in what we do. Multithreading, crossing the memory barrier has been mixed in with all these other methods that do other things. Like, for example, synchronize gives you lock, but also crosses memory barrier. Starts a thread, but also crosses memory barrier. So you can see how when two independent things get mixed in, it becomes problematic. Nothing could be as glaring as something else we have seen is in garbage collection. Well, Java has automatic garbage collection, great idea, but the automatic garbage collection is not instantaneous automatic garbage collection. So it takes care of cleaning up the memory at its own will, but what if I have resources to clean up and not really memory to clean up? Well, you could put that in the finalize method. When will the finalize get called? When the garbage collection kicks in. Wait a minute, these two are independent of each other. And so when you mix two things completely independent, we got more pain. This is consistent in our field. In programming, we end up mixing two completely different things together, and then we face the consequence. I don't think there's anybody who's exempt from it. Everyone has suffered through it. I do it in my code, you do it in your code, and of course, language designers do it at the library level and language level as well. And that is something for us to think about moving forward. Are we really mixing completely two independent things into one? And that is basically lack of cohesion, and lack of cohesion could be at a line level, a method level, a class level, a library level, and we see this consistently becoming a problem for us to deal with, and that is something we have to take the time to make sure we don't get into that kind of mess in dealing with these kinds of accidental fusing things. So, in other words, yes, syntax is something we all are running into every single day. But the next time you begin to look at a new library or a new language or a different style of programming in the same language that you are used to, almost everybody now is going to get used to functional style of programming in a mainstream language like Java, for example, which means we are going to get exposed to a different syntax, a newer syntax, and we are going to find it hard to get adapted to it. In the beginning, it's going to get really confusing. But what's really important is not just to look at the syntax, but to really go beyond it very quickly and get a really good grasp of the semantics. For example, in Java, you can call a stream, but the laziness of the stream is extremely important to understand. If we don't know that streams are lazy, it's going to be really problematic writing code with it, no matter how we understand the syntax. The syntax doesn't quite tell us about the laziness at that point. So I'm going to invoke Thoreau's words here, and I think this is something for us to all take back and think about. He says, it's not what you look at that matters, it is what you see. And I'm really hoping you will spend more time seeing the semantics rather than looking at the syntax. Thank you very much.